In this video, we're going to look at even, odd, and neither functions. So we have had some experience with these in the past. So just a reminder, an even function is symmetric with respect to the y-axis. An odd function is symmetric with respect to the origin. And if you think of an even function, the opposite inputs have the same output. So f of x equals f of x, f of negative x also equals f of x. But with an odd function, opposite inputs have opposite outputs. So while f of x equals f of x, f of negative x equals negative f of x. And that'll be a little bit easier to see, I think, as we go through some problems. I wanted to review some basic families with you. Ideally, this would be great for a group activity in a classroom setting, but we're not able to do that right now, so we're just going to kind of make do with what we can. So some basic families that you're familiar with are linear, quadratic, and rational. And then there are a couple other families that we're going to look at after that as well. So for a linear function, most linear functions are neither. Most of them are just going to be kind of random graphs. So if you think of a typical positive slope graph, here's your coordinate plane, and here's just a graph. Well, you're not having any of those situations. You're not having any symmetry with the y-axis or with the origin, except, and that's where it's always kind of tricky, there's always an exception that you can typically find. And if you haven't figured it out on your own, it is a horizontal line. So a horizontal line is got symmetry with respect to the y-axis. So if you had a point here that's 3, 4, then -3 would also have a y value of 4. So that's your opposite inputs having the same output, so that would be an even function. Quadratic and absolute value functions are kind of brother and sister. One is a U shape, one is a V shape. And if you think of kind of the parent function here, it's going to be even. So that will be even. Kind of the same thing. I could have 3, 9 if you were just looking at x squared, and then -3, +9 if you're looking at x squared. And if it was an absolute value, it would just be a V-shaped instead. And if your A value was negative, it would be flipped upside down. If it was a value of 4, it's going to be narrower. If it was a value of 1/4, it will be wider. And then if you had an add-on, it's just going to shift the graph up and down. However, if you put any other transformation left or right, or if you think of your standard form of a quadratic, the y equals a x squared plus bx plus c. If you have a b value in there, that's going to mess things up and it will no longer be even. So sometimes it's even, it will never be odd. It will never be odd. Rational functions, lots of things can happen. So with a rational function, the parent function 1 over x, y equals 1 over x, will look something like this. Okay, well, and then that would be an odd function. If you did -1 over x, it will still be odd. It's just going to be in quadrants 2 and 4 instead of 1 and 3. There are some rational graphs that kind of come here and have a hump and then keep going. That I didn't draw perfect. Sometimes they are. There are a lot of rational functions. Well, some rational functions are shaped like this. So that would be an even. This potentially could be an even. Sometimes you have those rational functions with a couple vertical asymptotes. So a lot of things could happen, because what if you had this guy and then this guy and then you had an S in the middle? Well, that's going to be nothing. Actually, I guess it depends. You'd have to check the values, because I kind of drew it shifted a little bit, because what if this was x equals 1 and x equals -3? That would be a nothing. But what if it was x equals 2 and x equals -2? This actually would be odd. So it depends. I would say in general, for even, odd, and neither functions, you always have to think. And that's kind of the big idea here. All right, continuing. Exponential and log functions. So we have exponential growth, you have exponential decay. So here would be a growth, exponential growth with a horizontal asymptote. Here would be a decay. Okay, these are not going to be even or odd. A log function, depending on the base. Remember, you're always going to have a vertical asymptote here instead of a horizontal. These have horizontal, so it could shoot up that way, or it could come down that way, depending on the function. These are all going to be none. Okay, so you're not going to have any of that symmetry for even and odd. Square root and cube root, if you have a square root of x, remember we talked about those, and they kind of have a starting point and they go up to the right. Well, that's not going to be even or odd, but the parent cube root function is odd. So if you look at that, I had a cliffhanger there for you. So it's going to look kind of like that. That's going to be an odd function. It's symmetric with respect to the origin. However, any shifts left or right will mess that up, or up and down. You can stretch it as long as you don't shift it left and right, and that would be fine. Polynomial graphs, most of them are going to be none, although you could have some that are odd. Let's say you had something like that. Okay, that would be a polynomial function, and then that one looks pretty odd, and you have to check it by points. So you'd have that rotation. So these are just some examples, and then we have our sinusoidals that I think I did mention a little bit. And for the sinusoidals, we have our sine, our cosine, and our tangent. All right, and then if you think of the parent sine function, parent sine is always going to be odd. The parent cosine will always be even. So you're starting at the max. I guess I could have given myself a little bit more room here, but you're starting at the max and you're going to go through this way. So the parent cosine is always even. And then if you look at a tangent graph, this is going to be x equals pi over 2, x equals 3 pi over 2, x equals negative pi over 2, and these are always increasing. So the parent tangent will be odd, and then again, you have to think through your transformation. So there's no quick way to do even, odd, and neither functions. In general, you do have to think. I did kind of go over a few main ideas for you, but in general, you have to think them through. So if you would like to write some of these down, you certainly can. This is page 53 from our packet. I picked like 6 questions to go over with you right now. So if you're just kind of watching this video and you don't have the packet, you could just pause it real quick and then jot these down. I have pre-programmed most of these into my graphing calculator. So I just wanted to kind of show you a few of these so you would know what to look for. All right, so for number 10, I have g of x equals x to the negative first plus x. So if you'd like to program these in, go ahead. You can type them all in, and then I'm going to select my equal sign kind of one at a time. I intentionally left y2 blank because the absolute value can be really tricky for people to put in the calculator, and I'll show you how to do that in a moment. All right, so the first one for number 10 is y equals x to the negative first plus x. I have my equal sign on. I'm going to zoom in and do a zoom standard. We were recently doing sinusoidal graphs, so I just want to do a standard. And wow, you kind of see this funky graph. So right now it looks odd. So it would be a rotation of 180 about the origin, which means it's symmetric with respect to the origin. And then this trace button is really super helpful. So if I type in 3, I get 3.3 repeating. If I type in negative 3, I get the same thing. So this one's looking like it is an odd function. Our question says determine if Each function is even, odd, or neither, so number 10 is odd. All right, I'm going to come back over here. I'm going to deselect that. And now for y2, I want to put in number 14. So this is an absolute value with an x cubed. So I have to go into the math menu and then scroll to the right to number, and ABS, number 1, stands for absolute value function. So I hit enter, and now I can type in x to the third. And then my equal sign is selected, so I can go ahead and hit graph. Honestly, I wouldn't really know what that looked like, and I'm kind of surprised that it looks like a quadratic. But now that I see the graph and I'm using my graphing calculator to assist me, this looks really even, and I'm going to just verify that. So I trace, and I get 2, 8. If I plug in -2, I still get 8, which now thinking about it, even if you did 5, you get 125. -5, you're still going to get positive 125. So you might have been able to think that one through. So this one's even. This one I think would have been a little bit harder to figure out. All right, I'm going to come over here to 17. And then this one is a square root graph. And we did look at this a few minutes ago. And if you think about it, it's a square root graph. So remember, it's got the hook. And now this one shifted right 3. So I'm expecting this one to be nothing, to be a neither, so not even or odd, and it certainly is just neither. So if you can think through it, then you don't need to actually use your graphing calculator to graph it, but I'm just going to sneak in a neither here as I go through. All right, next I'm going to look at a polynomial for 24. So I'm going to come down here, I'm going to deselect that, and I'm going to reselect number 4. So now I have the graph x to the third plus x squared minus x minus 1. I'm going to graph that. Okay, and this is a polynomial graph, but I really don't know exactly what's happening until I kind of focus in on some values. So if I look at 3, I get 32. If I type in -3, I get -16. So they are not in perfect alignment. So it has to be just right. The stars have to be aligned, right? So if it's not exactly right where your same opposite inputs get the same output, or opposite inputs have opposite output, it will be a neither. Many, and I almost want to say most of the time it's a neither, but there are plenty of special cases. So it's really one of those classic cases sometimes, and you really have to go through and think it out. All right, so to me, the polynomials are kind of tricky, and you got to kind of look at the graph here. All right, now we get to sinusoidals. So I picked 25. So I just said that the parent sign is odd. This is vertically stretched, but it's shifted down and it's going twice as fast. So you could almost do like a little sketch here. So here's my x-axis, here's my y-axis. So now it's been shifted down. So I'm at -5. It's going to be wider and faster. So that would be at 2 pi here. So I have 2 waves in there. Here would be like -2 pi. And I'm going to go 1 and then 2. Not the cleanest graph, but that's okay. It's clearly not even because it's not symmetric with respect to the y-axis, and then I can't turn it. So I don't even need to graph it in the graphing calculator. That one I just kind of reasoned out. But if I wanted to see it, here you go, and you can tell it's certainly not even, and it's not odd either. So this is a neither. Okay, and then finally we have our cosine. So cosine here, this one, remember the parent cosine is odd. No, it's not. The parent cosine is even. And then I'm going to go up to 7, and now it's going to be flipped and stretched by 2. So I'm going to go down to 5 and up to 9. And then here's my midline, and I'm starting low and ending high. The period hasn't changed, so here's 2 pi. There's 1, and then you would just keep going. And if you look, so the shifting up and vertically stretched and inverted, that's not affecting at all. So this one is still even. And now let me show you that in the graphing calculator. Since my sketch is just so-so, I would say I'm a little subpar here. But I kind of did that just kind of using my noggin instead of going right to the graphing calculator. But as you think through each one, each one is a thought process. Some of them are a little bit more obvious than others. I kind of hopped around, but I just wanted to give you an idea of what you're looking at for even, odd, and neither, and I hope this helps.